Now on to the last part of our lab is the post-lab. We're going to add the vectors in our pre-lab by standard vector addition. We have a 10.5 Newton vector here, and that's pointing in 40 degrees south of west, so I'll label that there. And our 10.5 is our hypotenuse. And then we have an 8.5 Newton vector pointing 55 degrees, and that is south of east. So I'll place it in there. Now remember our trigonometry, SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is the adjacent side over our hypotenuse. And the tangent is equal to the opposite over the adjacent. So we're going to use those principles to get the x and y coordinates. That's step one. Then we're going to summarize those x and y coordinates. Then we are going to Pythagorize the x and y coordinates, and then inverse tangentize those xy coordinate sums. And let's see how all that works. Okay, those are our keywords. So let's take the 10.5 Newton vector. We want to get the y and the x values for those. So every vector can be thought of as a right triangle. We have this vector. Here's our right triangle. In standard vector addition, we place everything going out from the center, the origin, just like we do in the parallelogram method, except now we're going to do this algebraically. So we're going to say the cosine of 40 is going to equal the adjacent x over our hypotenuse. So that's x over our hypotenuse value, and that's 10.5. And then we'll do the sine of 40 equals the y over hypotenuse. So it's y over 10.5. And we're going to place those values in our xy chart. Okay, it turns out our x is a negative 8.0, and our y is a negative 6.7. Now you might be wondering where those negatives come from. Well, this is pointing in quadrant 3. South of west, we have a negative x, which is and also a negative y. So this one's to the left and down, so that's why those are both negative. Now on this side, let's do likewise for our 8.5 vector. We're going to say the cosine of 55 is equal to x over 8.5. And then we're going to say the sine of 55 is equal to y over 8.5. And that's going to come up to be equal to 4.9 for the x, and the y a negative 7.0. Now one more time, let's take a look and see where those negative and positives value come from. We're now in quadrant 4. The x direction is positive there, but the y direction being downwards is negative. So when we do standard vector addition, we've got to keep track of our plus minus signs. Now we just add all these up. Okay, well, this one here is going to be equal to a negative 3.1. And this one here is a negative 13.7. So our first step was to get our x's and y's. Our next step is to summarize. Now we're going to Pythagorize in order to get a resultant vector. So I'm going to call this resultant vector r. That's going to equal the square root of 3.1 squared plus 13.7 squared. Notice how I'm not writing negatives in there. You could if you want to, but in your calculator you must parentheses the negative because we're actually squaring the whole number. I know they'll be positive when I'm done, so that's why I'm not writing it now. Then the resultant vector r is going to equal 14 newtons. Notice how I'm writing a number plus a unit with that. And then I'm going to inverse tangentize. Those are just keywords I came up with. It's just really taking the inverse tangent. Because I'm going to say the tangent of theta is equal to my opposite over my adjacent, which is my y over my x. So that's 13.7. And divided by 3.1. And notice again, I don't put negatives in there. You can if you want to, but I don't. And my theta comes out to be 77 degrees. Now we need a label for that. Well, my x sum is negative and my y sum is negative. Therefore, I know I'm in quadrant 3. So I'm going to label that as south of west. So there's always four things for any vector. A magnitude with a unit. A magnitude means amount of. And then a direction with a label. So why can we do this lap step? Why can we do Pythagorize and inverse tangentize? Well, if you can envision our parallelogram being something like this, and you've already drawn it with our pre-lab, this xy is the coordinates of our diagonal. So again, envision our diagonal being drawn somewhere through here. Okay, I'm kind of just highlighting where our parallelogram would be again. So our diagonal is going to be this right here. Okay, I'm just drawing a small line through there, just to kind of remind you, our diagonal would be there. This xy right here are the xy coordinates of our diagonal. So if I can Pythagorize it, can you see the right triangle there I'm trying to draw there? I'm not trying not to get too confusing. So we have a negative 3.1 for the x and a negative 13.7 for the y coordinates of that diagonal. We can just Pythagorize that together to get our hypotenuse, and we inverse tangentize to get the angle theta, which is right there. So that's standard vector addition. So now in this lab, you know to do a graphic method, which is the parallelogram method. And then we move on to the law of sines and cosines. And then the last method is just plotting the vectors in standard position. Get your x's and y's, summarize, Pythagorize, and inverse tangentize.